Good evening, students of class 12. Let us continue the chapter number 3 with the topic temperature dependence of resistivity. In this same video, we shall also draw graphs of this dependence. So keep watching the video till the end so that this concept is understood by you. I am Dhanusaria, continuing this chapter with the topic of temperature dependence of resistivity. Now, what is resistivity? Resistivity is a property of the material which classifies a material into metals, semiconductors and insulators depending upon their respective resistivity. Metals have lowest resistivity. Resistivity is denoted by rho, as you have seen. Okay, and normally ranges from 10 raised to minus 8 ohm meter to 10 raised to minus 6 ohm meter. Fine. So because the metals have lowest resistivity, they have the highest conductivity. Fine. Reason are proportional to rho. From the formula R is equal to rho L upon A. Fine. So if R is proportional to rho, then R is inversely proportional to conductivity. Correct? That is, R is inversely proportional to conductivity. So if resistivity is low, conductivity is high. If conductivity is high, it means the material will allow enough amount of current through the material. That is the meaning. Fine? Okay. Now let us go to semiconductors. Semiconductors have little more higher rho, more resistivity, so less conductivity, which is between metals and insulators. Fine. Small amount of impurity in the semiconductor can affect the resistivity of a semiconductor. Okay. So now we have the third classification, that is an insulator. Now insulator compared to the metal and semiconductor has highest resistivity, so least conductivity. That means the current is very less in an insulator or is equal to nil. Fine. Now resistivity of all these materials, whether metals or semiconductors or insulators, depend on the temperature given by the formula rho T is equal to rho naught 1 plus alpha T minus T naught. Fine. Where we have rho T is equal to the resistivity of the material at temperature T. Rho naught is the resistivity of the material at reference temperature T naught. Most probably for metals, reference temperature T naught is 0 degrees Celsius, and alpha is the temperature coefficient of resistivity. T is the given temperature that I have already mentioned, given temperature, and T naught is the reference temperature. Alpha is always a positive, that is the temperature coefficient of resistivity is always positive for metals. Fine. So, when we classify materials into three categories, metals, semiconductors and insulators, we also have alloys, which is a combination of metals, non-metals. Fine. So, we will discuss this temperature dependence of various materials with the help of the graph in the next page. Using this formula, which says that the temperature has a role to play in the resistivity of a material. Fine, I hope you have understood this concept. On the basis of this concept, we will draw graphs and explain the dependence of resistivity on temperatures for these materials. Take a pick, I shall move and try to understand this concept so the other will be easier for you. In this page, let us discuss the resistivity of metals as a function of temperature. So we are right now talking about the metals. Fine? Okay. So let us plot a graph between resistivity unit ohm meter and temperature unit Kelvin. So when we draw a graph, it is a curve but an increasing curve which shows us that as the temperature increases, resistivity also increases. Now to justify this graph, let us go to the formula which we have derived in the previous video. Rho is equal to 1 upon sigma equal to m upon Ne square tau, where m is the mass of the electron, E is the charge on the electron. Okay? And small n or n is the number of electrons per unit volume and tau is the relaxation time. That is the time spent by the electrons between any two successive collisions in the conductor or in the material. Fine. So, using this formula, let us understand the shape of this graph. Now, as temperature increases, the electrons will start colliding with each other faster compared to the previous temperature which was less. So, the relaxation time, that is the time between the successive collisions, decreases. Collision becomes faster, frequent, so relaxation time decreases. Fine? Okay. Now, in the denominator, there is N also. That is the number of electrons in the metal per unit volume. It does not depend much on the temperature. Fine. So it nearly remains constant. So what do we have? We have tau decreases. If tau decreases, m is constant, n is nearly constant, e is constant, and if tau decreases, then rho increases. So using the formula, rho is inversely proportional to tau. We can say as tau decreases, resistivity increases. Fine. That is what is the graph drawn. As the temperature increases, tau decreases, resistivity increases. So what is our final result? As temperature increases, it implies that resistivity also increases. Fine. Reason? Tau decreases, tau is in the denominator, so rho increases. So the whole concept is as temperature increases, resistivity also increases in a metal. I explain again, as temperature increases, collisions between the electrons will become faster. So the time spent between any two successive collisions is less. Tau decreases. If tau decreases, resistivity increases. So the final observation is, as you increase the temperature, resistivity increases. That is what is plotted in the graph. I hope you have understood this concept very clearly, and very nicely these questions are asked in the entrance exams as well as the board exams. In board, the explanation should be given, but in entrances, you should remember, as temperature increases, rho increases. Fine. Resistivity increases. If resistivity increases, let us go ahead. If resistivity increases, resistance increases. If resistance increases, current decreases in the metal. So till here you have to remember that when you increase the temperature, current decreases for a metal. Fine. I hope you have understood this concept very clearly. I shall just move, and please take the pic so that this concept is understood by you very clearly. Now in this page, let us understand the resistivity of insulators and semiconductors as function of the temperature, both insulators and semiconductors. The graph is a negative curve, as you can see. Now let us justify this graph again using the formula rho is equal to 1 upon sigma is equal to m upon ne square tau, where m and e are the mass and the charge on the electron, tau is the relaxation time, and n is the number of electrons per unit volume of the material. Fine. Now using this formula, we can say rho is inversely proportional to both n and tau. So let us increase the temperature of the material, whether it is an insulator or a semiconductor. As you increase the temperature, the electrons will start moving faster, and the time spent between two successive collisions is lesser. Therefore, tau decreases. As temperature increases, tau decreases. just as explained you in the previous page. And the number of free electrons per unit volume increases because of the increase in temperature. So, in the denominator, n increases and tau decreases. So, in the denominator, n increases and tau decreases. But the increase in n compensates the decrease in tau. So, the denominator increases. That is rho inversely proportional to n. If n increases, which is compensated or which compensates the decrease in tau, the denominator increases. Therefore, rho decreases. Due to this, as temperature increases, rho decreases. Temperature increases, rho decreases. As rho decreases, resistance decreases. Resistance decreases, current increases in an insulator or a semiconductor. So, as temperature increases, rho decreases, which is the graph shown here. Okay, so don't get confused between what is increasing and what is decreasing. Understand the concept. As the temperature increases, the electrons will start moving faster towards each other, so they will collide frequently. So the relaxation time tau will decrease, but the number of electrons which become free due to the temperature also increases. So the denominator increases, rho decreases. So finally we come to the first till the last. So first is temperature increases, rho decreases, and so on. So any of these proportionalities can be asked in the entrance or in our regular board exam. Be very careful what is increasing and what is decreasing. Accordingly, answer the question. Fine. I hope you have understood this concept, and even if you have forgotten what is happening by increasing the temperature, go directly to the formula. Give the reasons in your mind. Know the concept, and then you can arrive to the result very fast. Okay, so I hope you have understood. Take a pick. I shall move. Now in this page, let us understand the resistivity of an alloy with function as a function of absolute temperature. Now what is an alloy? Alloy is a mixture of metals and non-metals of various materials. Fine. Okay. So let us consider the graph first, which shows us that the resistivity and the temperature dependence is not very high. That means the temperature increases and resistivity increases, but not to a greater extent. Okay, the dependence is there, but the dependence of rho and T is less comparatively in alloys. Fine. So we can write down nichrome as one such alloy, which is a mixture of nickel, iron and chromium. There are other examples like constantan and manganese, which also has the same property, that resistivity and temperature dependence is very less. So these materials are used in wire bound resistors. Why? Because as temperature increases or decreases, as temperature increases or decreases, resistance nearly increases, decreases. Okay, resistance nearly remains the same, such that the current also passing through the wire bound resistor remains the same. Fine. So this is the reason why the graph is a straight line graph and the slope is not much. It is there but very less. Fine. Okay. So I hope this concept is understood by you very clearly and you will use it in your application questions, including the graph. Sometimes graphs may be given, you may be asked to find out the materials. Sometimes materials may be given, you may be asked to find out the graph or identify the graph. So for a metal or for a semiconductor or for an insulator or for an alloy, you should be able to understand the answer very clearly. Fine. I shall move. Please take a pick. Let us go for a quick revision of the formulas used in the JEE and NEET. Fine. Related to the concept resistivity dependence on temperature. So let us write down the first formula. Rho T is equal to rho 1 plus alpha T minus T naught. Fine, we can write rho naught also, where T is the given temperature and naught is the reference temperature. Fine, for the concept. Okay. We can also write RT, resistance at the temperature T, is equal to R naught, resistance at the temperature 0 or the reference temperature, 1 plus alpha T minus T naught, where T is the temperature given to us and T naught is the reference temperature, initial temperature. Fine. Then we have also used rho is equal to 1 upon sigma, which is equal to m upon Ne square tau, which we have derived in the previous video, where m and E are the mass and the charge on an electron, n is the number of electrons per unit volume of the material, and tau is the relaxation time. Now in this formula you can see that resistivity is inversely proportional to both n and tau. Using that concept, we plotted graphs of rho versus T, and found out for various materials, that is for metals, temperature increases, rho increases. If rho increases, resistance increases. If resistance increases, current decreases. This is for the metals. Fine. Then for insulators and semiconductors, as temperature increases, rho decreases. So R decreases. So current increases. Fine. This is for insulators and semiconductors. Now for alloys, mixture of metals and non-metals, the dependence of T and rho is very less. Fine. Okay. So this was what we have learned through the graphs. So this is a quick revision of resistivity depending on temperature. Take a pick. I shall move. I hope you have understood all the concepts very clearly and prepare for your respective exams. I shall move. Please take a pick.